Now, after writing this H1 star and H2 star, we can write V2 is equal to root of 2g H1 star minus H2 star divided by 1 minus A2 square divided by A1 star, and here we have written H1 star as P1 over rho g plus Z1 and H2 star is equal to P2 over rho g plus Z2. Now, we know that discharge is equal to mass flow rate without considering the mass. This is just flow rate Q. Flow rate is equal to area multiplied by velocity. So, generally for incompressible fluid we define the flow rate instead of mass flow rate. So, flow rate is equal to A2V2. So, in this equation, this is the equation from which we can write Q is equal to A2 root of 2g H1 star minus H2 star divided by root of 1 minus A2 square divided by A1 square. Right. Now, this can be further simplified and we can write in any other manner, but in this equation this A2 is a measurable term, because once the shape of the ventimeter is fixed or defined, then we can find out A2. And what is A2? A2 is the area at throat. And what is A1? A1 inlet area. Right. So, we know A1, A2, we know G, we can measure H1 star minus H2 star. Now, if we are using the U-tube differential manometer, then with the help of this formula, which we have studied when we discussed about the manometers, we can find out P1 over rho g plus Z1 with the help of this equation. Let me write this equation again. Suppose we have a 2 points which are connected to this U-tube manometer, So, and here since pressure was more, so it will compress up to this point, and here it will compress up to this. So, this is manometric fluid having density gamma 2, and here we have a fluid having density gamma 1. This is connected to throat and this is connected to inlet of the pipe. Now, with the help of this U-tube manometer, can we find out the pressure difference between point 1 and 2. So, what we do, we make a horizontal line here and find out the pressure at this point. What is the pressure at this point? Pressure at this point is equal to P1 over rho g plus this height, pressure due to this fluid. So, gamma 1 into H1, right, because P is equal to rho g H. We know that relations between pressure and height of the fluid. So, this height of the fluid or column of the fluid will exert pressure, and that magnitude of that pressure will be equal to gamma 1 H1. This must be equal to the pressure at this point. So, what is the pressure at this point? Pressure at this point is equal to P2 divided by rho g plus, due to this height is equal to say H2. So, gamma 1 H2 plus, due to this height, this is the fluid mercury having density gamma 2, say let us say, then plus gamma 2 multiplied by H2. What is this distance? This distance will be equal to H1 minus H2, H1 minus H2, right. So, with the help of this equation, we can find out, because P1 over rho g is unknown. and P2 over rho g is unknown. So P1 over rho g minus P2 over rho g, this may be brought to the left hand side and this will go towards right hand side. Minus gamma 1 H1 minus gamma 1 H1, and this will go towards left side, plus gamma 1 H2 plus gamma 2 H1 minus H2, right. So with the help of this equation we can find out, by measuring this height H, we can find out the pressure difference between 1 and 2, and we can substitute in this equation and we can find out the discharge.